Hi there, it's Mrs. Lindquist. So in part 2 now we're going to talk about interval notation. Interval notation is just a way of writing intervals out instead of using inequalities. So it's a way of describing a set of values. So the interval bracket -2, 7 parenthesis describes this interval in which we have an endpoint at -2 and we have an endpoint at 7. The bracket means that we are actually going to include -2 as part of our solution, so we will put a closed circle, and the parenthesis indicates that 7 is not part of the solution, and everything in between. So for example, 3, 4, those are all part of the solution set. So we can also write this as an inequality. So -2 is less than or equal to x, which is less than 7. So again, -2 is less than or equal to x is the same thing as saying x is greater than or equal to -2, and x is less than 7. So when we're writing something in interval notation, the brackets indicate that we are including the endpoint. And those would go with like less than or equal to or inequality greater than or equal to. So a closed endpoint or circle. So if you see a closed endpoint, you know you will be using a bracket. And then the other case is that you see a parenthesis as with the 7, which indicates the 7 is not included. We use parentheses when we are excluding the endpoint. And again, that goes with inequalities, just less than and greater than. So that would be an open circle on the graph to indicate that that endpoint is not included in the solution. So a couple other pieces of vocabulary we need to look at are the negative infinity and the positive infinity sign. So negative infinity means that the graph is going to go to the left forever. And the positive infinity sign means that the graph is going to get infinitely large. The last vocab word is this U-shaped symbol, which represents a union of two sets. And that would be used to write something like x is less than 2 or x is greater than 5, for instance. So you could belong to either set, but both sets are included in the union. All right, we're going to try out some examples. Use interval notation to describe each inequality. Graph on a number line. So for me personally, I like to graph it on the number line first. I want to see what this looks like. So x is less than or equal to 5. So I'm going to put 5 on my number line and a value bigger and a value smaller. And it says x is less than or equal to 5. So is 5 included in our set? Well, if we put 5 in, is 5 less than or equal to 5? Yes, because 5 is equal to 5. So we are going to include 5. So we're looking for values that are less than or equal to 5. So less than or equal to 5 would be to the left. So 4 would be one of our solutions. And we can test that out. 4 is less than or equal to 5, which is true. So when we're looking at this inequality, we can see that the highest that it goes on this number line is 5. And the lowest, well, there is no bound. This graph goes on and on to the left infinitely. So we would say negative infinity. So our interval is going to look like negative infinity, 5. Negative infinity actually says it's going on infinitely to the left, so you can't actually include the n because there is no n. So we'll use a parenthesis. And since 5 is included, we will use a bracket. So you will never use a bracket with either of the infinity symbols. And you want to write your interval notation from left to right. So you would never have a negative infinity on the right side. So example B, 2 is less than x, and x is less than or equal to 10. So the endpoints we have are 2 and 10. So 2 is less than x. So are we including 2 or not including 2? Well, is 2 less than 2? It is not. So we are not including 2. That would be false. How about, are we including 10? Is 10 less than or equal to 10? Yes, it is. It's equal. So we are going to include 10. And then we are going to include all the values that are in between. So our shading will go in between. So for example, 5 would be a solution, and we can test that out. 2 is less than 5, and 5 is less than or equal to 10. So it works out. So when we write our interval notation, we're going to look at our endpoints are 2 and 10. We are not including 2, so we're going to want to use a parenthesis, but we are including the 10, so we will use a bracket. So that is the interval notation. So go ahead and pause this video and try out C and D. And if you want, you might as well try out example E as well. All right, so let's take a look at example C. So we'll put -3, a value bigger would be -2, and a value smaller would be -4. So should we be including -3? Is -3 greater than -3? The answer should be no. We are not including -3 as part of our solution. So we're looking for values that are greater than -3, which would be to the right. So for example, -2 is greater than -3. Okay, so when we write this interval, we should have -3. This is going to the right infinitely. So positive infinity. And you can put the plus or not put the plus. If you just put infinity, we'll know. So we know infinity cannot be included because it goes on forever. And -3 is also not included. So we will put a parenthesis. How'd you do on that? All right, let's look at D. We have -7 and -1. So -7 is less than or equal to x, and x is less than or equal to -1. So are we including -7? We should be, because -7 is less than or equal to -7. And what about -1? Is -1 less than or equal to -1? Yes. So we should be including both endpoints and, again, everything in between. So for example, -5 would be in between. So for example, -7 is less than or equal to -5, which is less than or equal to -1. So that just guarantees that we have the right interval. So when we write our interval in interval notation, we'll have -7, -1. And because both endpoints are included, we should have brackets on both. Okay, for example E, 15 is less than or equal to x, which is less than 17. So because the less than or equal to, we are including the 15, but we are not including the 17 and everything in between. So for example, 16 would be in there. So our interval for this would be 15, 17, bracket on 15 to show it's included, and parenthesis on 17 to show that it is not. So let's look at part F. X is less than -2, or x is greater than or equal to 6. So we'll put -2 and we'll put 6 somewhere over here. X is less than -2, so we are not going to include -2 since -2 is not less than -2. And this graph is going to go to the left. So for example, -3 would be in this interval because -3 is less than -2. And x is greater than or equal to 6. 6 will be included since 6 is equal to 6. And numbers greater will go to the right. So 7 would be in this interval. 7 is greater than or equal to 6. So when we go to write this in interval notation, we're going -infinity all the way to -2. We don't include -infinity, and we are not including -2. In union, remember that U for union, with all values that are 6 or greater. So since we want to include 6, we should have a hard bracket, and that is going to positive infinity. And again, infinity, for the infinities, we should always have parentheses. So this is an example of unions of two sets of values. The last example, G, the set of all real numbers less than 3 or between 6 and 8 inclusively. So what does this word inclusively mean? Inclusive means including, which means that 6 and 8 are going to be included in our interval. So let's kind of put the numbers that we have. We have 3, and we have 6 and 8. All real numbers less than 3. Is that including 3? 3 is not less than 3, so we are not going to be including the 3. So less would be to the left, so for example 2 and so on. and then everything between 6 and 8, including 6 and 8. So we're going to include both of those. Interval in between there. So go ahead and pause the video and see if you can write a union of two sets of data. So we have from negative infinity to 3. So the 3 should have a parenthesis or a soft bracket, they call it, in union with everything from 6 to 8, including 6 or 8. So we should have 2 brackets. So this is the interval that we have. These are the 2 intervals that describe this graph. So how did you do? Well, in the future, we are going to be using more interval notation, and you will see that it shows up more, especially when you get into calculus and higher level math classes. You'll be seeing a lot more of this as we go. Okay, you guys have a great day. See you later. Bye.